Hi, this is an activity to show area of acute angle triangle. Okay, let's see how to do it. Let me remove the contents of the cover. I have four foam pieces, four foam right angled triangle, four right angled triangles, two big and two small. And I have a drawing board which is usually used by visually impaired to draw. It has a metal mesh and a frame. It's a rectangular board. Okay. So I'm just taking two big foam pieces and I'm examining it. I'm checking how they are. I'm touching. I'm touching all three angles. If I find that there is one angle which seems like a right angle. Now, if I want to check, then I can keep it at the corners, at a corner of this rectangular board. So I know it is right angle. I know where exactly the right angle is. Okay. So, and then I'm going to check that these two, the sizes of these two big right angles, and they are absolutely um, same. That means the two triangles are congruent. Okay, they call congruent triangles. I'm keeping that aside. I'm taking the two small ones and I'm examining the small ones too. I noticed that all the foam shapes have magnet on one side. Okay, so that side goes down on the mesh. Now, while I'm examining, I find right angle even in the small triangle. So I can check that again and I find that both the small triangles are also right angle triangles. And when I place them one on top of the other, I know that these two triangles are also congruent. So that means these two are same too. Okay. Now what I am going to do is I am going to keep the mesh frame horizontally so that the length is parallel to me, and then I'm going to place one big and one small triangle on the mesh lengthwise in such a way that the right angle is somewhere in the middle. Okay, and I'm making sure the magnet is touching the mesh, and I'm taking the smaller one, smaller right angle triangle, and I'm placing that also next to the triangle that I just placed, and in such a way that the right angles touch each other, the height touch each other. Okay, when I do that, I get a big triangle. And this time it is not a right angle triangle, it seems like an acute angle triangle. All three angles are acute angles. Okay, so that is a big triangle. Now, since I know that the two big pieces were congruent to two small pieces of triangles, I am going to try to make the same triangle again using the other two pieces and keeping them on top of the first triangle. And yes, I can make exactly the same triangle again with these two pieces. Okay, I'm just confirming this. Okay, so these two triangles are congruent. These two big triangles, which are formed by one big, one small triangle, are also congruent. Now, I'm going to take out the top triangle, the second triangle that I made, to the two pieces of the second triangles, and I'm going to place in such a way that I get a big rectangle with all four foam pieces. Now, the first triangle that I made is intact on the board. The second big piece that I have is placed with the hypotenuse of the first coinciding with the hypotenuse of the second, okay, on the board. So if I just look at two big triangles, then I get one big rectangle out of these two triangles alone. Similarly, I am going to keep the hypotenuse of the smaller triangles facing each other, touching each other, to get a smaller rectangle. Okay, now when I touch the whole set of pieces, I see a rectangle. If I want to make sure it's a rectangle, then I'll have to check that the opposite sides are parallel, and then all the angles are 90 degrees. So to check if they are parallel or not, this board actually helps me. So I can push it to both the sides and see that they are parallel. Okay, and I can push it breadthwise towards the border to see that they are parallel. Okay, I can't push it from a side. I have to push it from the center so that the whole rectangle moves together. Now, and then I can also check that they are 90 degrees because in the corner I can see it fits perfectly well. So all four angles are 90 degrees. Okay, now that I know this is a rectangle, um, let me find out the area of the rectangle. I already know that the area of the rectangle is length into breadth. Okay, length into breadth. Remember that this rectangle is made out of two congruent triangles. I'm talking of the triangle which made out of one big and one small triangles, the first triangle that we made. So therefore, the two triangles, the area of the two triangles is equal to length into breadth. Now we want the area of just one triangle, right? Just one triangle. The area of one triangle is half length into breadth, right? Now length happens to be the base of the small triangle, the base of the triangle. Now, half therefore the area of this triangle is half base into breadth of the rectangle. Now, breadth of the rectangle is same as the height of the triangle. Therefore, the area of this triangle is half base into height. So that is how we get the formula for the area of the triangle using materials. Now, this seems a little confusing in the beginning if we don't know a lot of concepts. But one, we need to know certain concepts about the rectangle, about lines being parallel, and how to basically identify it as 90 degree, touch the material and understand that an angle is 90 degrees, all that. And also about congruency, but these things are all graded in school. So you don't learn something like this in the beginning. And also, if you just play as a puzzle in the beginning, then children are exposed to something like this. So you just ask the children to make a rectangle out of four given four pieces. So they have to try. They can make a rectangle. They can make, they can figure out how to make rectangle with two small triangles, two big triangles. They'll try all different shapes. It is an exposure game. So children should be allowed to solve lot of puzzles. This is something like a jigsaw puzzle. So when they solve the puzzles, they are learning geometry incidentally. And when they come to higher classes, they already know properties of so many shapes. It's easier for them to understand. Okay, so puzzles and games are the beginning. Okay, all right, thank you.